The presentation, let's see. All right. Really is just gonna kind of be a recap because, like I said, we haven't really talked about landfills in this this group to my knowledge. It's been kind of an out of sight, out of mind topic. It's outside of town, and generally people just kind of assume they work. So we'll kind of go over what basics are for a landfill, more particulars on what freezeback landfills are, the regulators, current perspective on them, and where that leaves freezeback landfills. We already did this. One other topic, I guess, is just I've spent, like I said, I've spent a lot of time up here, water and sewer work. I've spent 3 winters in Point Lake with the group here, as well as 3 winters in Wainwright. So I've seen a lot of the conditions there change over time. Lot less time than Bill or some of the others, but it's changed dramatically even in my time. All right, so landfills are basically an engineered structure that's regulated by EPA, and in this case ADEC. There's federal CFRs that govern them. The whole goal is to provide environmental protections for a solid waste disposal. And we need to have that solid waste disposed of terminally. We can't have it leave the site. We can't provide contamination to a groundwater source, to the surface waters, or to lands. So there's containment structures that are built in that we'll cover here in a minute. And like I said, I'm not going to be quite as dynamic with this one. If you do have questions, go ahead and flag me on the way, and that'll help keep this a little more even keeled. Landfills have different classifications. Types of waste is a main component. There's some subsets that aren't listed there, and then they're classified by how much waste they receive per day, and that affects the regulatory criteria that affects the landfill, the reporting, and a number of other operational components. So this I stole from the reference there because this was probably the best visual I could find on landfills, just so the whole group kind of understands what we're talking about. We've got the original ground here, or soil barrier they're describing it as. From there, we go into a secondary containment system. This is used for leak identification on a primary containment system here. We have drainage systems and soil barriers between the two. We have more drainage systems around this primary containment liner. The pipes here are both used for leachate and groundwater monitoring. Then you go into a waste storage structure, and then a closure cap. You can have a porous layer here to where you can collect methane. The waste decomposes, and have more of a soil barrier, an impermeable layer to prevent moisture from going further into the waste. You're gonna have a liner on top, again, to prevent moisture from going into the waste, which all creates more leachate that you have to manage. You're gonna have a drainage layer above the liner to shed water off the liner, so that you don't have a large hydraulic head pressure to force moisture across the liner. Then you're gonna have more erosion and topsoil protections. Ultimately, you're gonna create methane collection system on top, whether that's just gonna be vents like you might have seen on the closed landfill here over by shop 3, or in the cases of more developed landfills, those may have an extraction pipeline that sends it someplace to a flare station or for beneficial use. All right, so the meat of what we're looking at here today is freezeback landfills. I don't have the history on when this was put into the Alaska regulations. It's not a federally regulated description, but there's certain criteria that do trigger this. We have to be on permafrost soils. Alaska Administrative Code defines it. Has to operate where we don't degrade the permafrost. And we have to ensure that the permafrost remains frozen throughout the open and closed life of the landfill. Let's see. Part and parcel with that, though, is as the name implies, we have to be able to freeze our waste. So that's where our challenge is. And we'll get into that here in a little more in here in just a moment. I queried DEC on this last week, and there's a total of 6 freezeback landfills that were permitted throughout Alaska. Those primarily affected class 1 and 2 landfills, the larger landfills that are under in operation. The class 3 landfills, the smaller village landfills, don't have the same operating conditions, so they are not permitted as freezeback landfills. All right, freezeback landfills do offer benefits to the operators, and it winds up being operational components and capitally driven components. We don't have to construct containment liners. We don't have to construct leachate collection systems. There's no groundwater monitoring, and there's no methane collection systems because the waste are not decomposing. A requirement, again, is to keep the permafrost frozen underneath the landfill. So that implies that we either have to have insulated pads or thick gravel pads to do that. We have to provide enough insulation over the permafrost to prevent it from decaying on us. And in order to do so, we have historically used gravel. And that does a few things. That a thick enough gravel pad has historically given us enough insulation to protect the permafrost. We slope it so that there's no surface water that's accumulating in the active cells. And again, we don't have any containment systems or leachate collection. So the other part of this then is, again, we have to keep the waste permanently frozen. So now we have to have a thick enough gravel cap to do that. Historically, we've just used gravel, no insulation, and that's provides the insulation to keep the gravel frozen. Problem is it also increases, I'm sorry, not a problem, because I get these backwards. We increase the albedo of the gravel cap because we generally grow on top of it. Again, the closed landfill by shop 3, you'll see that we've got quite a bit of vegetation growth on it. So it's not just a brown spot on top of the tundra. The gravel caps are also designed to shed water so that we can keep moisture out of the waste, so avoiding that heat transport into the waste mass and causing thawing events. The caps are still low permeability, similar to the other requirements. One issue though is the soil types that we're using dictate what the cap thickness needs to be. So historically in Barrow here, we use finer grain soils, silty sands for cover, but the new gravel pit is more coarse material. So our cap thicknesses may increase because of the thermal resistance is less. And again, freezeback landfills don't need a liner in this case because everything's supposed to remain frozen. One change for freezeback landfills, though, is a requirement for thermal monitoring. It's something that's been done on slope for years, and it's added to these sites for confirmation that we're keeping the waste frozen. In this case, it's just kind of a typical thermal monitoring well at one of the landfills and a normal whiplash curve that we'd see for annual temperature swings at a monitoring well on a landfill. Those are 5-foot grids. All right. So the freezeback landfills require similar planning efforts in order to develop the landfill. You got to define a surface area for a solid waste management plan, identify the waste streams and the characteristics that are going to be disposed of at the landfill. We also, as part of that, have to identify a useful life of the landfill and the airspace that's going to be required for the volume that you're going to fill through that life. And then you have to describe how landfill is going to be closed, how it's going to be used, and how the operators are going to monitor it after it gets closed to make sure there's not going to be any environmental issues. And then you go into, the similar things we've just talked about, design of the landfill proper, pad thicknesses, containment structures, erosion control measures, site-specific hazards, seismic, groundwater, proximity to airports, and then for freezeback landfills, thermal stability. And that's really where we are struggling at this point. So past freezeback landfill authorizations, and this isn't intended to be a criticism of things done, just status of where things are today. Modeling was done, but it wasn't scrutinized very heavily. There was no requirements by regulators for specific models other than just to say, yes, it's going to stay frozen for the period presented. There was no specific climate models that were requested. There was no periods that that model had to represent. And so I think it created an artificial bubble that these facilities were operating in that are creating a problem now. So moving forward in time a little bit, 2017, DEC had announced that they're no longer going to allow freezeback landfills by public notice. That public notice was rescinded for a couple of reasons that we won't get into, but that didn't stop their intent. They've raised the bar for any new landfills or any expansions of landfills that were freezebacks or intended to be freezebacks. And that has created a challenge because that bar is super high. And they're still not describing any requirements for thermal modeling or horizons other than permanently frozen. They're not saying use an 8-degree increase. They're just saying you have to tell us what it's going to be forever. And that really creates a problem because we have low confidence in 20-year forecasts, let alone 50 or more. So we've gone through some extensive efforts on landfills for thermal modeling. This is snippets from one that we've had a firm here in state do for us. And we've gone through a lot of different iterations. We've gone through different type material classes as you might be able to read, maybe not. The one on the left, sandy silt and silt. The one on the right's sandy gravel. And these are equivalents to give you an idea of visually of thermal resistance requirements to keep something frozen today.
2 minutes.
Okay. All right, this is thermal modeling similar for those two scenarios. We've got closed scenario, waste day 0 when the landfill's closed, and then once we get our cap on it, what those freezing conditions look like for warmest scenario. So status, basically freezeback landfills are rated just by an economic consideration. New constructions of landfills, requirements for closure are going to be closer to 15 feet. Currently, we're about 6 feet, so it's a significant cost increase just for closure. I mean, we could get them permitted now, but we're passing the buck down the road, and that requirement's only going to increase in the future. It creates new issues for operators because these facilities are now going to have to go conventional. We have to do liners, and that's clay liner with geosynthetics twice, leachate collection systems, which we have no terminal location for disposal. And we have a lot of fact finding to do in order to make these successful. We also going to be doing groundwater monitoring and permafrost, so as valuable as that is, and more methane monitoring now too. Just a couple of graphics, and I know I'm out of time now, but the other challenge is it creates a thicker pad. What I'm seeing is to get all these structures in the pad for collection systems and monitoring, our pad thicknesses are going up 50%. So we're even adding raw material side before we talk containment liner structures and everything else, just to get a landfill built. And that all factors into issues for operators for training and maintaining new systems. Just a quick summary of options for leachate disposal. Wastewater plants can manage it if it's not hazardous. We could do a reduction and reinjection into landfills, injection wells, or hauling off to outside sites. And again, it's going to increase landfill operating costs, and that's going to factor into waste disposal rates.